Welcome, Chapter 7, Use of Locks in Physical Crime Prevention. This chapter we're going to discuss physical crime, the terminology of locks, lock components detailed, as well as ways of looking at them. So we're going to take a look at all the different types of locks, how they all work, everything from the tumblers work to keys, the different types of keys that are required. So this is what the lesson in physical locks. Examine key-operated mechanisms, combination locks, understand the different types of doors and door locks, and apply countermeasures. So the terminology, design, manufacturing, installation, and maintenance. Everything has a key in it. Is a key component of making sure that locks are safe, and materials protected, and this goes from your home to the businesses. What kind of locks are they? But basically, we're trying to figure out if the better we understand how locks work, the better we can implement the correct lock for our circumstances. Just like everything else we've been talking about in this class, comes down to money. And what are we protecting? If I'm protecting a $10 item, I'm not going to spend $100 on a lock. Same with your home, businesses. What are we protecting and how much money do we want to spend? And the technology. We can go fully automated. We can be old school with keys. So it just depends on what we're trying to do. Let's take a look at the keys, right? Lock terminology. We need to understand every lock has a weakness and strengths. How do we use each to achieve maximum benefit? Inner workings of different lock types. Basic principles. So it's a little of everything we want to look at, because if we know the weaknesses, we can then build upon that to determine what their strengths, what we were looking for. Key operated locks have basically interior physical wards, tumblers that prevent locks from opening if they're not properly aligned. The key is the device to unlock them. It has all the grooves in it, so the grooves basically act as a mechanism to ensure the tumblers all line up once the locks are in. Once the key is in place, the tumblers line up and allow you to turn the lock to open a door. That's the basic summary of how a lock works. So how does a tumbler mechanism? This is the inside. This is what almost every lock has, some type of tumbler in it. You line it up, it allows you to open it. If the tumblers aren't lined up, then we can't open. Let's see, may have a disc, lever, or pin. We'll talk about the differences of those in a little bit. But it has a key, it has depth, has the ridges on it, and again, the idea is to make sure all the tumblers are lined up before they turn. And there's every tumbler, every manufacturer has different set. Excuse me, you have different set of whether fixed or variable that allows us to use what we need. Fixed specifications, dimensions of each component, establish clearance of the part, and allows us to open a door. So depending on how we want, relationship between the tumblers, we can have fixed openings, how far each valley or peak on the key is available to us so we can see what's going on. That's all that is. And then you have different ways that you can look at it. So each tumbler, different arrangements of tumblers, the number of tumblers you have. The more tumblers, the more secure, the number of depths. Makes it harder to copy. And that's all we're trying to do is how many tumblers, and this shows you that one tumbler has a length of 10 combinations, 2 tumblers have 100 combinations, and 3 tumblers has 1,000. So again, what is the security that we want? And that's what we're trying to figure out. Not all combinations are possible. Shredding combinations allow key removal from tumblers. Equal depth combinations are avoided because then if they're the same, it makes it easier to unlock. Combinations that cause a weak-end key and combinations that cause space from one key cut to erode spaces to another key cut. So we want to make sure that everything is set. They're not randomly. They have a science behind them when making the keys and the tumblers to make them work. List of total combinations. Again, what are we looking for? What do we want to pay for? The total number ranges from 1, certain types, warded locks, and few security tumblers, millions of them, depending on what we want. 3 separate parts, right? We have the key, we have the cylinder plug, contains the tumblers, and the shell. And this is what almost every lock with a key is made up of as we look at it. And it allows us to have this information so we can see what's going on. The wafer tumbler, 3 separate parts, the key, cylinder, and plug. The plug contains the tumblers, which are usually spring-loaded flat plates that move up and down in the slot cut through the diameter of the plug. Variable dimension keys, slots are cut into each tumbler. When no key is inserted, the improper key is used. 1 or more tumblers will not be engaged on keeping the lock from opening. Disc mechanisms, only moderate secure. 4 to 5 depths. There's only a couple keys. First common 5 tumbler mechanisms. So there's not super secure. More secure are the warded keyways, can be manipulated. Picked easier can be sight-read manipulating tumblers with a thin wire to note position. So these are some of the downfalls of that. Pin tumblers are most commonly used. Like the disc tumblers, has equal drivers, so you can see the key goes in and the discs will rise, allowing you to turn the key to unlock the door. When the key is inserted, the top of the pin's aligned flush with the cylinder to the shear pin, allowing us to turn it, as you can see. If it's improper key or is not in correctly, all the discs won't move up, not allowing the unlock to be unlocked, the lock to be unlocked. And we have different size tumblers that we can use, depending on what we want to do. The depth of them, either 12 thousandths or 20. Again, what are we trying to protect? Between 5 and 10 is normal. Maximum combination, 3 pens, is approximately 130 combinations. You get up to 6, it's 65,000. So the more tumblers you have, the more discs, the more secure it is, the harder it is to get into, for anyone to break in. So these are some of the different things we got to keep in mind. Pin tumbler mechanisms usually are poorly constructed, wide tolerance of cylinders, minimum number of pins, and port chambers. High resolutions, precision cylinders, maximum number of pins, so we can look at some of the different pins that are out there, the tumblers that are not all the same. Most use warded keys. The worded key corresponds to the grooves in the key, and the par-centric keyway. Words on one side, key extends. So it's not only up and down, but you have the keys on the side, the grooves on the side. So they have to match also. So you have the tumblers that are matching, and you also have the side mechanism that's matching. So it makes it harder to pick locks if you have to look at it from the side in the top view. And these are some of the different things that we want to look at. We also can have a mushroom shape. pin tumbler. We have a spool shape. So these are different shapes that we can have. And again, the different shapes that we have that makes it harder for people to get in using picking devices if they're mushroomed, shear pin sights, multiple pins going in. Usually in most locks, the core can be removed, allowing it is. Entry through the lock system, pin tumblers. When core is removed, any flat tool can open it. Added control pins to increase shear points. So again, depends on the lock we want to buy. A master key is a simple master key system using master pins in the first and second tumbler positions. When the change key is inserted, that the remaining positions show the key pins aligned at the top. The arrangement permits a plug to be turned. So the master key is changing the first couple of them and not really affecting all of them, but it allows you to open a door. Open the lock. Security problems with master keys. They can be unauthorized keys. Master keys reduce the number of useful combinations. If a submaster key, even fewer. Cross keying is too many locks in a series. One key fits several locks. And usually in a business world, this is very common. All the people have the same locks on their doors, and the cleaning people will have a master key to get into everything. And again, these are some of the issues that we run into. Who has the key, master key? And there's different types of things. You have the ring that fits around the plug. Some keys can be cut into either sleeve shear or plug shear line. Requires use of more master pins. And again, having the master key allows you to open any door with that key set, as long as it's all programmed. Common to high security cylinders, extremely close tolerances provide very high numbers of usable combinations. Use very hard metals. Lever tumbler mechanisms. Very similar to the pin. Unlike the pin or disc tumbler devices, the lever does not use rotating core plugs on the bolt, which is integrated in. The only other type of mechanism in which keys directly engage in the bolt. And again, it's more of a lever to open it up. It works very much like a tumbler, but horizontal versus vertical. And it has a leaf spring attached to it to kind of make sure that the keys tumbler overlaps. The leaf spring is attached to the lever bolt. The bolt prevented it from moving back to retract, and the face trapped by the front edges of the lever. And again, it works similar. It just goes in, so we can put it in and make sure that it's there. Levers will not be raised as far enough to align. One or more levers will be raised too high, and these are improper cut keys. These are moderate to high security depending on the number of levers, configurations, the degrees that are there, and a set of double levers that are on there. They're usually found in safe deposit boxes, strong boxes, post office, or lockers, not super high, something simple to use. Combination lock uses numbers, letters, and other symbols to enable it to align it. They're usually wheels. Each has a slot milled into it designed to engage the face. The sequence that permits locks to open its combination. You have to have it all lined up. It could be numbers. Again, having it lined up. Combination locks Most have no more than 4 tumblers. As the dial rotates, cams can rotate and allows us to have this in. It's usually a wheel that you'll have, multiple wheels that kind of when they line up, pin goes in and it engages it. Floating pin, so it allows us to have what's going on. Combination lock. It's usually 3 wheels, dial turned 4 times in one direction to nest the first wheel, and then reverse direction, and so on. So it's a combination, so you can kind of see. And these you see on the safes. Security varies the number of tumblers you have, the number of positions on the tumblers, where the gate can be located, tolerances. So everything goes into these different tumbler devices. And again, it works. Usually got to change it in both directions, so it has what we have in there. And you have the different tumblers, cylinders. The more tumblers, the harder it is to get in. Let's see. Let's get to lock bodies. Most lever tumblers are awarded mechanisms contained in an integrated part of the mechanism. The key operates directly to throw the bolt, thereby opening the lock. On a true pin disc lock, it consists of 2 major components: the cylinder plug, the shell, and the tumblers and the springs contained in an assembly unit. The bolt assembly translates rotating cylinders, plug motions to the back and forth, motion operating the bolt. When the cylinder inserts into the lock of the body, connects the bolt, assembly by a tailpiece. Pin tumblers are usual mechanism in locks and doors, standard residential commercial doors. Called the latch bolt, called the latch bolt, or a spring latch, automatically tracks when the beveled facet contacts the door. Latch springs in to extend it, convenient but not necessarily secure. This is your typical door bolt as what we look at. So when we close the door, you have that strikes in. When it clears, it pops out to keep you from opening it again. Again, a very simple locking mechanism. The throw is usually 3/8 to 5/8 of an inch, depending on the door jamb and how everything comes together. Anti-friction latch bolt, designed to reclose. Reclosing pressure requires force latch bolt retracted, permit heavy spring to be used, often incorporated with anti-shim devices. Deadbolt. Deadbolt has a square face usually. No, it's not spring loaded. It needs the key. And you put the deadbolt in and it locks the door versus just incorporating the lock. It's usually about a 1/2 inch in diameter with a throw of about 1 inch. And again, unlike the latch bolt that automatically opens and closes, this must be manually operated to close. Again, if you think about it on your house, you have the doorknob, you turn the doorknob, open it up, that is the latch bolt. You have the key, that is your deadbolt. Interlocking deadbolts increase security, expanding the deadbolt so you can have multiple anti-friction ones, anti-shim ones that require us to have more security. Door types, mortise, rim. We have the different door types that we can implement. And again, a mortise, installing in a hollow portion of the door, holes are on the side. The weakness, the door must be thick enough. The cylinders hold in the lock with the set screws and can place the guard. A rim-mounted door lock installed on the surface of the door, usually on the inside of the door, usually supplementary locks. You usually have a key to operate it. Tubular is installed by drilling holes through the door to accommodate the cylinder and cylinders. And the installation. Again, this is very similar to what most doors have. The cylindrical lock set, fastening element installed like the tubular lock, cylinder mounted doorknobs, makes them vulnerable. Like it says, about 85% of all residential locks, this is what they use. Very low security, also inexpensive. A unit lock is installed by making the U-shaped cutout in the front of the door and then slipping it in the lock into the cutout. This type of lock usually has an advantage as having no exposed screws or bolts, and it is ordinarily used to place the mortise lock where the door is too narrow for the mortise. So these are some of the other types of locks. Cylinder locks. Mortise cylinders threaded into the lock, secured with small screws, and tubular rim locks interlock the screws from the back out. Singular cylinder locks, key operated cylinders on the outside, thumb key, double cylinders, key hard for the intruder to get in. A padlock. They are used to shackle rather than bolt as the device samples. A shackle is placed through a hasp, which is permanently affixed to the item to be fastened. 3 methods are commonly used to secure a shackle inside a lock body. The simple and least secure is the press to piece of a flat spring steel against the intention. Locking dog, loaded and it fits the notch of the shackle. Both mechanisms are vulnerable to attack. Device can be forced back against the spring. Shimming and wrapping, stiff wire usually works. Do not use for reasonable security. Positive locking method, most common, steel balls. If locked, the shackle cannot be forced past the steel balls. When turned to unlock position, ball retracts, release the shackle. Cannot remove key unless it is in the locked position. Vulnerabilities of the padlocks: shackle pried out, shackle sawed off, hammered to destroy, reduce vulnerability, heavy steel, rotating inserts, and toe and heel locking. These are some of the different things that we have that we need to take into account. There are high security padlocks, large and heavy, hardened materials, thick, and the hasp locks. No better than the hasp it engages. Should it be hardened metals, proper mounted on solid materials, not acceptable through screws. Hasp lock is the same quality. So as you buy a cheap lock, a padlock, it's not going to work. Strikes are often overlooked, but essential part of a good lock. A deadbolt must engage a solid, correctly installed strike, or its effectiveness is significantly reduced. The ordinary strike for a residential use is mounted with 2 or 3 short screws, wood screws into a soft door frame. It's easily pried open with a screwdriver. High security and wider ones incorporate a lip that wraps around the door, usually 3-inch screws, and then the screws should be in line, right? Used to reinforce steel and metal framed doors, especially aluminum. Use bolts, mount the strike in metal frames. These are some of the different things. Some attacks and countermeasures. The 2 force is the easiest one to get through. And as we said before, nothing is 100%, so even locks can have a problem. Average pin tumbler is important. No lock can survive strong force applied. Sole object of a lock is just to delay the intruder. Countermeasures reduce vulnerability. Not all appropriate for every application, and we need to look at it. Cheap padlocks on warehouses are not helpful. Again, what are we trying to protect? Overprotection often more harmful than it. If a complex security system is necessary, owner likely will not use it. Many unlawful entries through unlocked doors and too inconvenient. So again, what are we trying? Having a plan, as we talked about at the very beginning of our class a couple of weeks ago, is what are we trying to protect? And we want to make sure we have the appropriate amount of protection. And this goes down to our door locks. I can have the best system in place, and what this particular slide is talking about is that if it's too complicated, no one will use it, and that totally circumvents the whole purpose of the lock. So when we have put in systems, we have to make sure that the lock is appropriate for what we're protecting. How do we get illicit keys, circumvention, manipulation of interior barriers, shimming? These are some ways that we get it. Thousands of keys are lost every year. Make sure you leave your house key, leaving your house key on a ring while the car is serviced. Easy to get home address from repair bill. So these are some of the things that we want to look at. Maintaining reasonable key security. Remove all the keys when you drop your car off. When duplicating keys, make sure no extra keys are made. Some locks, remove the key code. Maintain a strict control over the master key. Ensure lost keys cannot be linked to. Never put your home address on your keys or who it belongs to. Replace compromised locks. If a key falls, if someone steals your keys, change the locks. You can just have the tumblers replaced as we saw at the beginning. Try out keys. Replicas, common tools, common variations, particularly in commercials are available. Intruders may build their own set. Defense, use the locks with a moderate to high number of available combinations. Completely bypass locking mechanism. Long, thin, stiff tools. Bypass internal barriers. Tool maneuvers, bolt. Manipulation, at least 50 types, categories, picking, impressioning, decoding, wrapping. These are all different ways that criminals use to get into, let's take a look. Picking, slight tension placed on the part of a retractor bolt. Pin is this. Someone's using a very small device, shear pins to adjust the pins. Pin chamber is rarely very perfectly aligned, so as long as it's close, it can be picked. Each pin is tested by lifting it with a pick. This is just how it. Rack picking, sight tension applied to the plug, and rake is run along the tumbler, lifting the shear line. Again, these are all things that how picking can be done, variations. How do we resist it? Having a high quality lock that has very tight tolerances, it makes it harder to get into. Force misalignment, adding more tumblers, 12 pins to 14 are some of the different things that we can do. Pin design, resistance, how do we prevent this? Mushroom pins, spool pins, huck pins. Again, the shape of the pin makes it harder for us to use as we start building this. apply, if you're going to decoding, apply rational tension applied to the blood causes the misalignment, and as we can see, it has this thing. The pin tumbler cylinders with wide tolerances are more susceptible to decoding, so we want to make sure, again, what kind of lock are we buying relies on the pins and the bind and how we want to get through this. Decoding is usually made on padlocks, not encased in a door, modified manipulation, resistance pins, high security padlocks close to tolerances. Shimming is another way that we can pick locks. And basically, it's a spring-loaded latch that can be shimmed with a thin piece of plastic or metal tool that helps protected by anti-shims if you don't have it in. And the padlocks, they put in the shim to make sure everything works, aligns. Forceful attack, any lock can be punctured or broken or twisted or burned. Forceful attacks, if they have the time and the means, most locks can be penetrated. To a disadvantage to an intruder who does not want to be discovered, large and cumbersome tools makes noise. Obviously, to the observer, the lock was attacked. Increased hazards. A jimmy and prying. A jimmy is a short pry bar. Other things, pry bar, crowbar. Again, using this to force open the door jambs, you can get most bolts can be in. Even using a screwdriver, non-interlocking throw, deadbolts. Again, some of the different things that we can put in that can be attacked. Usually deadbolts can be by prying them open. It does take a significant amount of energy to get it open, depending on the deadlock that it's there, if it's into a wood frame, metal frame, on how it will be attempted. As I said, a car jack, which is used to open up doors, can also be used to open up framing by breaking the wood. Attacks on the deadbolt. Attackers need to punch right through the wall. Framing to reach the bolt. Several attempts may be necessary. Punch and hammer the bolt back to lock it. Most bolts will succumb to a punching attack. And it's a last resort. Very messy and noisy. Using a hacksaw. Again, if it's hardened, the better locks are hardened. Hacksaw will resist this. Freewheeling rollers inside the bolt. Sawing actions will not cut through if it's round. Attack on cylinders, prying out, drilled, punch. Again, you can just yank out the cylinder. You can put in a pull and pull out the cylinders. And again, that will just defeat the entire process. A slam hammer or dent puller is used. You screw it in and you just pull it out. And it will take the pulling of the lock mechanism right out. Many cylinders are burnable, poorly anchored. Mortise cylinders aren't good. Tubular rims, retaining bolts. These are usually very small and can be easily manipulated. Again, the pulling mechanism, lug pulling, wrench pulling, these are some of the different types that are out there. And again, they're just used to pull out the lock. Once the mechanism, the tumblers are removed, the door can be opened. And this can be done with pliers and twisting and ground screwdrivers to insert into the keyway. Cylinder guards so that it can't be, to help prevent the twisting of the entire lock. They just spin, so you can't do anything with it. Central lock, some freewheeling doorknobs provide protection, a breakaway knob, some things, different things. Again, what are we trying to protect? Drilling out, drill holes, and it will just come right out, and we can get this. Let's see, the remount we talked about. Hammering, drilling, hammering, these are some of the different things that we can do. We just hammer it out to break in. Key control, another thing. Who has access? Who has the keys? Is there a cabinet that has all the keys in it? Who has the recs? Key blanks. Some keys, I know where I currently work, I write on the key, it says do not duplicate, so I can't take it to a store and have it duplicated unless they're an authorized person to make duplicate keys. So this is another way. Key control is a big part of this. Who has the inventory, daily, and all this. Lost master keys must be entire complex. All right, that was chapter 7.